Hello everyone. So this is a question from NEET 2026. Match list 1 with list 2. In list 1 we have certain compounds and in list 2 we have the kind of bonds that they have. Okay. So the chapters involved is chemical bonding. So we should know that hydrocarbons are organic compounds which consist of only carbon and hydrogen. And one way of classifying them is into alkanes, alkenes and alkynes. Okay. So alkanes consist of CC single bonds and they have the general formula CnH2n plus 2. Alkenes consist of CC double bonds and they have the general formula CnH2n. Alkynes consist of CC triple bond and they have the general formula CnH2n minus 2. Okay. So coming back to the options, in A we have C2H4, which is an alkene. It follows the general formula CnH2n where n is equal to 2 and its name is ethene. It is also known as ethylene. So its structure is going to be C double bond C and CH, CH. Okay. Remember that a double bond is always made of one sigma and a pi bond. And a single bond is always a sigma bond. So these are all sigma bonds. Okay, so therefore, um, you can see ethene has 1, 2, 3, 4, 5 sigma bonds and one pi bond. Okay, so ethene has 5 sigma bonds and one pi bond. So therefore, A is matched to 4. Then we have in B, we have C2H2, which is an alkyne and it follows the formula CnH2n minus 2 where n is equal to 2. Okay, its name is ethyne, also known as acetylene. Okay, so therefore its structure is going to be C triple bond C H H. Okay, remember that a triple bond is always made of one sigma. So out of these three bonds, one of them is a sigma bond and two pi bonds. The other two are pi bonds. And we know that single bonds are always sigma bonds. So therefore, you can see ethyne has 1, 2, and 3 sigma bonds and 1 and 2, 2 pi bonds. So ethyne has 3 sigma bonds and 2 pi bonds. So therefore B is matched to 1. In C, we have CH4, which is an alkene. It follows the general formula CnH2n plus 2, where n is equal to 1, and it is methane. So therefore its structure will be CH, H, H and H, right? And all of these are sigma bonds. So therefore you can see methane has 1, 2, 3, 4, 4 sigma bonds. Okay, so therefore C is matched to 3. And then we have in D, we have NH3, ammonia. To know its Lewis dot structure, count the number of valence electrons in all the atoms of NH3. Okay, so total valence electrons, or the valence electrons are also known as the electrons present in the outermost shell, is going to be, so in nitrogen we know its configuration, it is 1s2 2s2 2p3. So outermost shell has 3 plus 2 5 electrons, plus in hydrogen we know its configuration 1s1. So outermost shell has 1 electron, but there are total 3 hydrogen atoms, so 5 plus 3 into 1, so this is going to be 8. So therefore we have to distribute 8 electrons between 4 atoms which are present in NH3. make sure that there is at least a single bond or two electrons between any two atoms. Okay, so making N as the central atom, and obviously it will be surrounded by three hydrogen, and giving them giving minimum two electrons between any two atoms. So I will have 2, 3, 4, 5, 6. Okay, so you can see six electrons are present as bond pairs, 2, 3, 4, 5, 6, right? And the total valence electrons are 8. So therefore 8 minus 6, that is 2. So those two electrons are present as lone pairs on nitrogen. Okay, so you can also draw ammonia in this fashion. Instead of writing these two electrons, we can show them by a bond. So NH, NH, it has a lone pair, right? So therefore you can see ammonia has 1, 2, 3 sigma bonds and one lone pair. Okay, so NH3 has 3 sigma bonds and one lone pair. So therefore D is matched to 2. Okay, so the final answer is going to be A4, B1, C3 and D2. Okay, thank you.